The theme of my research is reducing the influence of reverse traction current on automatic train signaling in a railway section with heavyweight trains. Electric traction is widespread on the Russian railway network. It is more environmentally friendly and more economical kind of transport than autonomous traction. Railway transport in the country, due to the developed infrastructure and relative cheapness, remains relevant. The weight of trains has an upward trend. On electrified railways, rails are one current conductor. Signal current to control the position of the train at stations and stages also distribute along the rails. The main purpose of the study is to identify the most vulnerable nodes of train position control devices and develop measures to reduce the influence of traction current on the operation of these devices. The novelty of the study is to determine not only harmonic frequencies of the traction current, but also the influence of the location of transport of infrastructure objects near the rail. Metal structures and the contact network, especially in multi-track sections, are located asymmetrically relative to the axis of the track. This asymmetry implies the heterogeneity of the electromagnetic field of the contact network. Therefore, unwanted currents are induced in the rails. The degree of field's heterogeneity and the maximum values of the induced currents are determined using CAMSAL multiphysics modern software. This software performs mathematics calculation and also allows you to visualize the results of calculations. Based on the calculated values, in the places most susceptible to inducing currents, an experiment will be made to verify that the calculated current values correspond to the actual ones. During the simulation, it was found that the rails of double-track section located in the middle are most affected by train position control devices. To level this phenomenon, it is recommended to introduce asymmetry elements that align the currents of one direction in the rails, and they compensate each other without affecting the operation of train position current devices. Methods of suppressing interference induced by traction currents can be applied everywhere on network of electrified railways. The study has practical applications, contributing to an increase in the carrying capacity of railway without compromising safety performance. Implementation of the results of the study should reduce the number of failures with the result of the investigation. The reason is not identified.